Assalamu alaikum. Nermin Noori postgraduate, College of Health and Medical Technology. Today discuss the second part of seminar number 14, CAD-CAM system in implant dentistry, supervisor by Assistant Professor Dr. Sajid Ali Mohsen. Role of CAD-CAM in dental technology. Computer-aided design and computer-aided manufacturing is begun utilized in many fields besides dentistry. In the manufacture industry, which is a crisp, highly detailed CAM method is used to produce a prototype. Several authors have suggested that CAD-CAM may improve the accuracy of dental implant planning and placement, an extension of this application, and the ability of fabricated dental prostheses prior to the implant surgery. The CAD-CAM system. After the entrance to the CAD-CAM in the field of dentistry, there are several systems, which include Porcera, Lava, Everest, Circon, Circ 3, Circ Lab, and the DCS precedent. CAD-CAM system may be categorized as either in-the-office or laboratory system. Circ is the only manufacturer that provides both in-office and laboratory modalities. Laboratory CAD-CAM systems have increased significantly during the last 10 years and include DCS Precedent, Porcera, Circ Lab, and Lava. Circon is a laboratory system that possesses only CAM capabilities without the design stage. This slide contains two pictures of a Porcera system. Porcera system, all serum, was introduced in 1994 and produced 3 million units as of May 2004. Scanning acquired a 3D image of the master die. The processing center then generated a large die designed to compensate for the shrinkage of the ceramic material. Very technique sensitive because the degree of die enlargement must precisely match the shrinkage produced by the sintered, the alumina or zirconia. Excellent clinical longevity and strength. Scanning machine manually. Also, the CAD program custom, design and database, and the CAM process fully automatic. The second system of the CAD-CAM is a Lava system. Lava system introduced in 2002 used laser optical system to digitize information from the multiple abutment margin and the edentulous ridge. The framework Lava system is designed to be 20% larger to compensate for the centric shrinkage. After the design is complete, probably size semi-centered zirconia block is selected for the milling. This system also have 8 different shades, 2 color. The framework for the maximum aesthetic. Scanning machine optical. CAD program customs. Design and the database. CAM process fully automatic. This slide shows the third type of the CAD-CAM system, the Everest system. Everest system marketed in 2002. Consists of the scan engine and the component. Machining unit has 5-axis movement that is capable of producing detailed morphology. Material include lucite reinforced glass ceramic, partially and fully centered zirconia, and titanium. A process center dental lab, scanning machine optical, also the CAD program custom design and database, and the CAM process fully automatic. The fourth type of the CAD-CAM system is the Circon system. Circon system is a 2001 is a market launch, is commonly referred to as a CAM system because it does not have CAD component. The system scanned the wax pattern and mold zirconia bridge copying from the pre-centered zirconia blank. Dental lab process center. Laser scanning machine, also no CAD program, and fully automatic CAM process. Now discuss about the 5 type of the CAD-CAM system. is the CEREC 3. CEREC 3 with a CEREC 1 and the CEREC 2. Market launch 2000. The prepared tooth is made with the couple charge device, camera, and a three-dimensional digital image is generated on the monitor. While the system is modeled the first restoration, the software can virtually set the restoration back into the virtual cast to provide the adjacent contact while designing the next restoration. A process center is a chairside, optical scanning machine, CAD program custom design, and the CAM process fully automatic. CEREC Lab is the sixth type of the CAD-CAM system. CEREC Lab market launch in 2001. CEREC Lab is a laboratory system in which the working die and the laser scanning and the digital image of the virtual model is displayed on the laptop screen. The laboratory technician inserted the appropriate Vita and Serum block into the CEREC Lab machine for the milling. Dental Lab Process Center, laser scanning machine, CAD process custom design and the database, and the CAM process fully automatic. In this slide show the last type of the CAD-CAM system is a DCS President. Market launch of the DCS President in 1989. DCS President system is comprised of the pre-scan laser scanner and the pre-mill CAM multi-tool milling center. The DCS dent form software automatically suggested connector size and the pointing forks for bridge. Dental Lab Process Center, optical scanning machine, CAD program custom design and database. CAM process is fully automatic. After we know about the CAD-CAM system, I will explain to you a treatment planning for the implant-based restoration. The first phase of the implant dentistry is planning. It is insufficient to identify an edentulous space or missing tooth and simply initiate surgery. First, diagnostic wax-up of the proposed tooth form and ideal location must be achieved. From this radiographic guide is fabricated that simulates the wax-up. Next, diagnostic image must be done in order to determine the alveolar bone available for the implant placement. It becomes possible to obtain a three-dimensional digital image. This is an accurate assessment of the height and weight of the alveolar bone available for the implant placement. Also, I will explaining the digital planning and the guided surgery in this slide. The implanted procedures planning should start much time before the implant placement surgery or even the choice of the implant itself. This is concept of the reverse planning. The emergence of the computerized tomography has revolutionized the image exam by the obtaining of much clearer image of the anatomical structures and the three-dimensional reconstruction, associating the concept of the stereolithography and the CAD-CAM technology. It's become possible to generate prototype surgical guides with the high precision. This technology is based on the real image of the bone anatomy obtained through the CT scan and the design of the computerized prototype surgical guide to implant placement based on mathematical 3D models. And the CT scan image are manipulated on the specific software, enabling a virtual surgery stimulating the implant placement, always looking for the best position. Bone anchorage, of course, respecting the future prostheses that these implants will receive. Also, the guided surgeries are suitable for the most varying type of the rehabilitation with the implants. This technology has been widely used with the significantly proven success to achieving optimal aesthetic and functional result. The guided surgery may be considered as a viable alternative for the rehabilitation of the edentulous space within the correct indication. The highlight of this technique is the detailed planning necessarily performed prior to the surgery, a fact that should be routine and should be performed in all clinical situations. Computer guided. The use of the CAD-CAM technique for manufacturing surgical drill guided assists the physical transfer of the implant planning to the patient mouth, this improving accuracy and visibility of the final implant placement. Our topic now, the CAD-CAM technology in implant dentistry. The CAD-CAM technology represented a major revolution within the current context of the modern dentistry. It is now possible to generate the virtual model from the direct digital scanning from the mouth, models or even impression, enabling the design and manufacture of the structure by the computer assistants. With this technology, it is possible to manufacture structure for implant bridge, custom abutment, bars, copings, surgical guides, and everything that can be developed in the software. Implant position within the virtual model of the patient mouth considers the available bone density, the distance from the adjacent teeth, and other implants, the fixture of proximity to the sensory nerve, and the relationship with the prosthetic end result. The designed implant placement are transferred into the surgical field by means of the customized surgical guide. The surgical guide is produced through the additive manufacturing process and geometrically controlled before performing jawbone osteotomies. Also, in this slide, I will explain the virtual design of the implant placement. Functionality of dental prostheses with respect to the biomechanical and aesthetical characteristic requires as well design implant positioning. Fixture should be placed at least 1.5 mm far from adjacent teeth in order to avoid loss of interproximal height of the bone and papilla. Moreover, adequate access for oral hygiene and corrected gingival contour require a bone thickness in a vestibular palatal dimension at least 2 to 3 mm greater than the implant diameter, even if there are no sufficient evidence to establish with the absolute confidence the minimum vestibular bone thickness for an optimal aesthetic outcome. 3 mm implant to implant distance has demonstrated to provide adequate papillary fill. The accurate fitting of the guide with the original plaster dental model is manually checked. A drilling sleeve are then inserted and glued in the template, which represented the actual guiding system for the surgeon drilling operative step. Therefore, final check is directly carried out into the patient mouth in order to verify the proper fitting onto the dentoalveolar arch where soft tissue are present. After explaining the virtual design of the implant, now we will take the patient case. Case number 1, fully edentulous patient. The patient is 52 years old man, represent a fully edentulous upper jaw, and a full arch replacement plan with the dental implants was selected to treat the edentulism. The desired prosthetic outcome was modeled on the 3D digital mouth model by using the CAD platform. The diagnostic prosthesis was manufactured by the rapid prototype technique using two materials, transparent photopolymer for the soft tissue and the radio-opaque agent for the teeth. Also, the next step, optical and the CBCT data were geometrically matched, superimposing radio-opaque reference service and the optimal CBCT data, their should value was achieved. Also, this slide contains two images. Two images is clarify a total of 7 implant and the 3 transalveolar horizontal stabilizing pin were virtually inserted within the integrated 3D data model. The next step, designing and manufacturing the surgical guide of the basis of the data extracted from the planning software. Also, the accuracy of the manufacturer surgical guide was verified by the comparing the 3D reconstruction obtained by the optical scanner with the plant model. This image in this slide clarify the plant implant precision, angulation, and depth was guaranteed by the flapless guided surgery. This is the last slide from the case number 1. Immediately after implant placement, the abutments were placed on the fixture and the professional prefabricated prosthesis checked. Final preparation of the inner surface of the prosthesis was performed using an acrylic resin in order to achieve perfect fit on the abutment. Resin is excess was carefully removed and finally inserted and screw returned during the same surgical appointment. Now discuss the partially edentulous patient in case number 2. 44 years old partially edentulous patient was referred for the dental implant restoration. The virtual model was graded by the digital mouth model and the ideal prosthetic outcome was virtually designed by the CAD software. 4 implant and 2 transalveolar horizontal stabilizing pin were planned. And also a rapid prototype surgical guide was designed and produced. Also, after the surgical guide was designed, the implants were inserted using a totally guided flapless surgery approach. Immediately after surgery, the temporary restoration was screwed on the fixtures. This picture is some of the restorative materials used for the CAD-CAM. CAD-CAM system based on the machining of the pre-centric aluminum or zirconia blocks is combination with a specially designed veneer ceramic satisfy the demand of the old ceramic posterior count and fixed partial dentures. Many ceramic materials are available for use as CAD-CAM restorations. Common ceramic materials used in earlier dental CAD-CAM restorations have been malleable glass ceramic such as Decor or Beta Mark II. Decor and Beta Mark II are not strong enough to sustain occlusal load when used for posterior crown. For this reason, aluminum and zirconia material are now being widely used as dental restorative materials. After know the restorative material, we will take every system. The restorative materials in CEREC system include Decor, Floramica, Vitamark 2 Feldspathic, Pro-Cut Lucite Reinforced, Indication Inlays, Olay, Veneer, Anterior Crown, Adhesive Dowel Cured, Conventional Cement, No Conventional Cementation. Also, the restorative materials used in CEREC 3D is in serum spinel, magnesium oxide, in serum aluminum oxide, in serum zirconium oxide. The indication interior crown and bridge. Adhesive cement, self cure. Yes, conventional cementation. Also, the restorative materials used in CEREC lab is the in-serum spinel, magnesium oxide, in-serum aluminum, aluminum oxide. Indication a crown on the interior bridge. Adhesive cement is the self-cured. Conventional cement, yes, conventional cement. While the restorative materials used in a porcelain system, which include aluminum oxide, partially centered zirconia. Indication a crown on the bridge. Adhesive cement, yes. Self-cure, yes. Conventional cement. But the restorative materials used in zircon system is a partially centered zirconia. Indication in a crown on the bridge, yes. Self-adhesive cement, also conventional cement. And in lava system, the restorative material is a partially centered zirconia. Indication in the crown on the bridge, and self-cured adhesive cement, yes. Conventional cement. And the reverse system. The restorative materials used in a reverse system is a partial centered zirconia, fully centered zirconia, zirconium oxide. Indication in the crown and the bridge. Adhesive, self-cure, and the conventional cement. The figure of this slide shows the restorative materials used in the DCS precedent system. These materials, which include the in-serum aluminum oxide, in-serum zirconia, zirconium oxide, partially centered zirconia, and fully centered zirconia. Indication in the crown and the bridge. Self-cured adhesive cement, and with conventional cement. After know the restorative materials used in CAD-CAM system. Explain about the history of the CAD-CAM technology in implant abutment manufacture. The first manufactured CAD-CAM abutment technology utilized in the implant abutment of orthodontic was described in 2000 as the Atlantis custom abutment technology. In collaboration with the Atlantis component, secured the first patent on the computer-aided virtual design technology for implant abutment. The first step of abutment manufacturing is the master cast was made from the intraoral transfer impression that located. Number 1. The intra-arch position of the implant to be restored. Number 2. The soft tissue contour around the implant. Number 3. The neighboring teeth. And the number 4. The opposing occlusal clearance. This master cast and its opposing cast were scanned individually and then virtually articulated within the design software. And the next step, the virtual abutment design template of the incisors, canine, premolars, and molars could then be modified using numerous measurement and design tools to create a virtual patient-specific abutment. Also, the blank is used milling of the abutment should be include the abutment's co-access different abutment connection to accommodate many different implant systems. The hex, either the internal or external, the capsule contour and the occlusal morphology, shoulder or chamfer margin, and the abutment base which was shaped to maximize the ideal tooth preparation from the despite suco excess. After we know the milling of the blank is explained about the Atlantis virtual design as the custom and the custom abutment milling technology is used to manufacture titanium, gold hue, and the zirconia custom abutments. In this slide, clarify about the differences between the posterior abutment and the Atlantis abutment. The posterior abutment contour were the result of the technician wax-up morphology, but the Atlantis abutment titanium abutment did not rely on the technician great wax-up for the abutment contour. The posterior bulk abutment was attached to the implant via the metal connection element, but the Atlantis titanium abutment did not require separated metal connection component to engage the implant. The Porcera system is a closed system that can only utilized with the novel BioCare implant. But the Atlantis technology is not a closed system. It can be employed with over 50 different implant connections. After we know the differences between the Porcera and the Atlantis abutment, now explain about the virtual abutment design of the custom abutment. The procedure shows the mandibular right posterior quadrant that is to be restored with the single crown and two implants supported. A dental surge with the implant and the prepared tooth scanned master cast on the off tooth. The next step, different view of the virtually occluded master cast and the opposing cast. Also, this image shows the virtual crowns over tooth, virtual crown meshwork, and also virtual correction of the alignment of a poorly angled implants. And also should be abutment in place with the opposing occlusion and the eventually restoration in place. After we know the virtual abutment design, we should explain the machine modeling of the custom abutment. Although the custom abutment began as the traditional cast gold abutment, today the most frequent material to be used are titanium, zirconium oxide, and plaster. Custom abutments are molded from the titanium or ceramic rod once the virtual design of the abutment is completed. The digital abutment fields guide with the cutting tool of the milling machine in 6 degrees of the freedom, so the different abutment material to manufacturing finishing custom abutment. Milling machine range in size, rate of abutment production, and cutting degree of the freedom. And also, this machine molds long rods of the commercially pure titanium within its milling chamber. Approximately 12 different abutments can be cut out of each foot length of the titanium rod. The milling takes place under copious amount of the cooling water spray. Thanks for listening.